Hey guys, new lecture starting. From today, we will learn about electrical circuits. So we will learn actually about most important part. We will learn R, resistor, L, inductor, and C, capacitor. We will learn it, okay? And if you guys understand this, and then later it will really help you guys to understand the, motor, generator, transformers. You got it? So let's start. Today we will learn about electrical resistance and Ohm's law. Okay? So look at that. Resistor, something, interrupt. Look at that. Yeah, here's a good example. Look at that. The energies wanna go, but something, prevent it, interrupt it to come through, the line, right? We say this is a resistor. Okay, in the circuit you can see this is a resistor, and look at that. Here's area and length, right? Here is a P is just a resistivity. You know what I mean? Each material has their own resistivity, right? We generally use copper or aluminum, right, for cables. So look at that. If the length is long, length is proportional to the. So for example, what I mean is, if length is longer, resistance gonna be up, and if the area is more bigger and bigger, which means resistance is reduced. So as I said, this upper side part is proportional. It is non-proportional underside, right? That's it. Resistor is just simple, right? We could understand something prevent or something, interrupt. Current interrupt, you know what I mean? Let's look at them more. So this graph indicates, look at that. The temperatures, it's when the temperatures is increased, also resistor is increased. That's it. You know what I mean? So it's a high temp, which means it's a high temperature. Our resistor is, gotta be more, get resistors better. You know what I mean? A little bit more. It depends on the material, right? Here's aluminum, copper. That's right? Just to see, just to try to memorize something like if the temperature is going, increased, and also resistivity is also going up. You know what I mean? That's it. And this is Ohm's law. We will always use it. You know what I mean? Ohm's law. Look at that. Generally, we use it Ohm's law for, practically, we wanna know about how much current it is. That's why we use Ohm's law. Or we also could use it like try to find out the voltage. For example, I'll show you guys. Okay, let's move on. So Ohm's law is really important. Where is it? Okay. Okay, I said V I R. This is the voltage. This is I. This is resistor. You guys will, learn about more about the electrical laws like Kirchhoff's laws, Ohm's law, many things, So this is the basic one. So we wanna find out voltage. This is equal this. I multiply resistor current, and I it could be also right. Yeah, and R like this. So if you remember just one or this one, you could use it. Yeah, to find out the voltage, current, resistor, right? That's it. This is the Ohms law. Yeah, just memorize, okay? This yeah, law. So for example, look at that. Here, for example, we wanna know about current, right? I. Get that. So we only know voltage and resistor. So using the equation, the I is 5 ampere, right? And the next part, okay. But there's a series and parallel circuits, two things, okay? So in the series circuit, the R resistor, we just add the value. If there's 1, 2, 3, series means, it's you guys know series and parallel means. Series is connected straightly, in the one circuit, right? So look at here's R1, R2, R3 is connected, right? So for example, what I say is if it's 1, 2, 3, just value is 1, 2, 3. So what is the total value? 1 plus 2 plus 3. Total value is 6 ohms in this case. But parallel, this is important. So you in series, if we add more resistor, the sum of values is increased, right? But in parallel, it's gotta be reduced. That's you guys confuse what I'm saying, right? Let's see, for example. Here, look at that. This is a parallel, right? First one. Using the formula and see it, you will see amazing thing. Yeah. The total reduced value is the sum of values. It's gotta be reduced. 2, 3, 6. Even there is a 6, 3. It gotta be 2. And 9, 9, 9. It gotta be 3. 12, 12, 12. It gotta be 4. Yeah. Look at that. So try to understand practically. We use a voltage source system, right? Voltage is constant, and R is, you say, you try to understand load, like we use it, right? It could be computer, it could be refrigerator, it could be your cell phone charger, right? This is load, right? So practically, yeah, when we use our load, it's connected parallel, not series, in reality. You know what I mean? So if we use more and more resistor, resistor means load, right? For example, if we use one computer, that's three computer, for example. So which means the total load resistor is reduced, which means, what does that mean? This is a constant V and R is reduced. That's why I is increased. Yeah, try to understand what we are actually using in reality. V is a constant because we use a constant voltage, voltage source system. So V is constant. R is depends on, but R is, I said, load, right? What we are using, the electrical stuff. Electrical, yes, energies needed stuff, like, for example, computer, TV, refrigerator, you know what I mean? So it's a connect in parallel, which means if we use more and more load, which means since it's a connect in parallel, the current is increase. That's today's most important part. Yeah, today's lecture is easy, right? That's it today. See you guys.